next chapter is chapter 7. And chapter 7 was all about solving right triangles. So any information that involved solving out right triangles. So first off, the first thing we talked about with right triangles was Pythagorean Theorem. That should hopefully be drilled right into your brain by this point, because we've used it so much. You should be sick of seeing c squared equals a squared plus b squared by this point. Hypotenuse is the longest side. We're probably going to have more than one question that's going to ask you to solve Pythagorean Theorem, because we used it so much throughout the year. We also talked, there's also going to be an application question, and it's probably going to be pretty similar to the one on the final exam review. So when I say applications, that means that I'm going to throw a word problem on there that's going to ask you to draw a picture and use Pythagorean Theorem to solve the problem. For these two, 30, 60, 90, and 45, 45, 90, the main thing that you need to know how to do is to identify a 30, 60, 90, and a 45, 45, 90. Because remember, one thing to keep in mind is that if you come across a 30, 60, 90, or 45, 45, 90, it's meant to be a shortcut. It's meant to be a shorthand way of writing out things. But if you want to solve it with the trig stuff I'll talk about in just a minute, then that works too. If you just don't know your 30, 60, 90, and 45, 45, 90 rules and you just want to use trig, then that'll work just fine. But the 30, 60, 90 rule, here's 30, is that we have this side across from the 30 is our short leg, and then that's this hypotenuse is double the short leg, and then this is my short leg times the square root of 3. That was our 30, 60, 90 rule. Our 45, 45, 90 rule is that the legs were congruent and that the hypotenuse was those legs times the square root of 2. And those were ways to give us shortcuts for solving out those triangles. So if I gave you this was 6, then you could say, oh, this is 6 and this is 6 square root of 2, done. That was the idea, is that it was a shortcut. But again, you can use trig to do it as well. You can use your sine, cosine, and tangent, and that'll work as well. So that's Pythagorean Theorem and our right triangle patterns. Now I'm going to move on to talking about trig. On your note sheet, I would absolutely write down SOHCAHTOA. And there are probably going to be about 5 or so trig questions where I'm just asking you solve for this side length using sine, cosine, or tangent. Or solve for this angle using inverse sine, inverse cosine, inverse tangent. Because remember, the inverse trig is for solving and writing out the inverse trig is for solving out the angles, and trig is for solving out the sides. There are some where I'm going to ask you to write the ratio. So I'm giving you the triangle and you're asking what is cosine? Well, cosine is adjacent over hypotenuse. So write out the adjacent on top, hypotenuse on the bottom. On trig, I might also throw a word problem on there. For example, I might give you one where it says, here's the angle of elevation of this thing. I'm going to give you a picture and ask you to find a certain side length in the picture. Again, expect about 5 of these questions where I ask you to use trig to solve for different sides and angles. And those are kind of all the tools that we use to talk about and solve for right right triangles. And if you're looking on the review, then that is numbers 1 through 14. So that's kind of the very beginning of the review. That's what focuses on the solving right triangles. So those are the questions that you want to look at if you want some guidance on the type of questions I might ask.